Something you may not be familiar with is the study of trigonometry. We're going to look at trigonometry involving right triangles, and one of the most important concepts in there is the idea known as SOHCAHTOA. Let's take a look at that. A right triangle is a triangle that contains a right angle, and you could draw it differently, but I'll do mine that way and put the right angle down there in the corner. We would name the vertices of our triangle, and I'm going to call that vertex A, this vertex B, and this vertex C. What that does, it also gives us names for the sides of our triangle. The side that is opposite from angle A is side A. Notice we use a lowercase letter to name the side. The side that is opposite from side B, or excuse me, angle B, is side B. And then finally, the side that is opposite angle C is side C. So that's how we're going to name the pieces of our triangle. Other names we've got for the pieces of the triangle are legs and hypotenuse. The hypotenuse is always the longest side of a right triangle. It's always going to be opposite the 90-degree angle. And then the other two legs of the triangle are called legs. So we have two legs and a hypotenuse. You may remember these terms from studying the Pythagorean theorem. Three of the main trigonometric functions that we're going to work with are sine, abbreviated with sin, and that's equal to the opposite side divided by the hypotenuse. The cosine, which we abbreviate cos, is equal to the adjacent side over the hypotenuse, and tangent, which we abbreviate with tan, is equal to the opposite side over the adjacent side. If you're wondering, what is this SOHCAHTOA business you're talking about? Well, we have sine equals opposite over hypotenuse. So sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. Cosine equals adjacent over hypotenuse. And finally, tangent equals opposite over adjacent. Tangent equals opposite over adjacent. And that is where we get SOHCAHTOA. It's a way to remember which one's the sine again? Oh yeah, that's opposite over adjacent, because SOHCAHTOA. Right. Sine is opposite over hypotenuse. I think I just said sine was opposite over adjacent. I guess I better relearn this myself. It goes SOHCAHTOA, which means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent equals opposite over adjacent. Let's look at the pieces of that together. If we go back to a right triangle and we label the vertices A, B, and C, and that tells us that we know our side names are lowercase a, lowercase b, and lowercase c. Now let's take a look at, for example, the sine of angle A. We remember from before, sine is opposite over hypotenuse. So when I look at angle A up here in my diagram, the side opposite angle A has this measure. The hypotenuse has this measure. So if I knew those values, I just divide those, and that would be the sine of angle A. It would be a numerical value. What if I wanted the cosine of angle A? Well, now if I want the cosine of angle A, now I need the side that is adjacent to it. That's sometimes confusing for students. I can see in my picture, okay, that's opposite angle A. Well, this one's the hypotenuse, so the adjacent must be the other one. Well, the one that's adjacent is just the one that's next to it. It's right here next to it. So that's the one that's adjacent to angle A. It's the one that touches the vertex. So if I want the cosine of angle A, that's going to be the side that is adjacent to it divided by the hypotenuse. Now let's look at a couple examples with some numbers. Let's say we are given a right triangle, and we can call it ABC. That's kind of been our normal thing to do. We've got our right triangle, so we've got a right angle down in the corner. And we are told that angle A has a measure of 33 degrees, and the hypotenuse has a measure of 50. Could be centimeters, could be feet, could be miles, doesn't really matter for this example. And our job in this problem is to find the value of side A. So the first thing you do is, well, I know sine, I know cosine, I know tangent. Which one of those am I supposed to use? Well, let's think this through for a minute. I've got an angle measure of 33 degrees. I've got the hypotenuse, and I've got the side that is opposite. So which one of those uses opposite and hypotenuse? That's the sine. So what I'm going to set up for this problem is that the sine of 33 degrees is equal to the opposite side divided by the hypotenuse. There's my equation that now I'm going to solve. I'm going to put sine of 33 into my calculator. Most of you will probably type 33 and then press your sine button. That's typically the way that that's going to go. When you do that, you're going to get a really long decimal. In our homeworks, just for the simplicity of writing it down, we're going to round that to 4 decimal places. So the sine of 33 degrees is going to be 0.5446. On your quizzes and exams, don't round. Keep all the decimals. That's going to be equal to A over 50. And I've got a little bit of algebra to do here. I need to multiply both sides by 50 in order to get A by itself. So I'll do that. I'll multiply this side by 50, and that cancels, leaving me just the A. I'll multiply 0.5446 by 50, and I get 27.23, and that is the answer to the question. What's the length of side A? 27.23. Let's look at another example involving the same triangle. We're going to stick with that same right triangle that we're going to call A, B, C. And angle A is still going to be 33 degrees. It won't be 33 degrees in all of yours, that's for sure. And let's say that we are told that side A is 85, and what we want to find is side B. So what's the measure of side B in this triangle? Well, here again, okay, I have sine, I have cosine, I have tangent. I've got to figure out which one to use. In this particular problem, I've got the angle, I've got the side opposite that angle, and I'm looking for the side that is adjacent to that angle. So let's see. Opposite and adjacent means I need to use tangent. So in this one, the equation that I'm going to set up is that the tangent of 33 degrees is going to equal opposite over adjacent. And now I need to find out what B is. Again, in my calculator, I'll go ahead and find the tangent of 33. Probably going to do that by pushing 33 and the tangent button. And when I do that, I get 0.6494. Remember, in our homework, we're rounding off to 4 places. On the quizzes and exams, don't do that. Keep all the decimals. So 0.6494 equals 85 over B. Now B is a side length here, so I know it's not equal to 0, so it's okay for me to multiply both sides by B, and that'll be my next step. So when I do that, I get B times 0.6494 equals 85. And then the last step I need to do is divide both sides by 0.6494. And when I do that, and I do 85 divided by 0.6494, I get 130.89. And that is the solution to my question, 130.89. One thing I want to point out here is the diagram that we made of triangle ABC to start this problem, that was just a sketch. It wasn't, I didn't know the side lengths, so there's no way it could really be accurate. So the fact that my answer of 130.89, well, wait a minute, this 85 looks like it's bigger than your 130.89. How can that be? Well, remember, I didn't know what the values were when I drew the triangle. It was just a sketch to help me set up my problem. Once I have the problem set up, if I do everything correctly, this is my answer, regardless of what that might look like in the triangle that I drew to start with.